All right, so the first thing that we need to talk about is what is a system, because we're going to be talking about systems of equations. That's the whole chapter, solving systems. So a system of equations is when you have two or more equations that have the same variables. Now, we're going to get to word problems later or practical examples, but usually this deals with when you have two equations that are related to like the same thing, and so they kind of act as constraints. But we'll deal with that later. So for right now, we just need to know that a system of equations is two or more equations with the same variable. A system of equations. So a solution to a system is always going to be an ordered pair. So a solution is an ordered pair that makes both equations true. So now I'm going to go over, there's kind of an idea about this section that I need to make sure that we understand. And
sorry to barge in.
okay, so you guys don't actually have to write this down. I just need you guys to follow along for a second. Because the first thing that I want to talk about that we wrote down in that definition is that the solution is an ordered pair. And that's kind of a new idea for you guys. So I want to talk about that for a second. Okay. So again, you don't have to write this down. This is just to help you guys understand. When we're talking about an equation with two variables, okay, what is the solution to that?
It could be a y. Y equals a negative x plus 10.
Well, that would just be like solved for y. But is there like a set answer to that? No. Okay. But what we're talking about an ordered pair as a solution, remember a solution is a value or values that make it true. Okay? So if you have more than one variable, your solution is going to have more than one part to it. So for example, would that be a solution?
Yes.
Okay, yeah. You've got, and remember your first value is always x and the second's y, right? So that would be a solution, okay? Is that a solution?
Yeah.
Yeah?
Why is it a solution?
Because
If you plug them in, it would make the equation true.
Oh, got it.
Okay.
Got it.
So any ordered pair here that makes the equation true is a solution, okay? Now, I could list off a whole bunch of these, right? 8 and 2, and I could reverse it and say 2 and 8. And there's a lot of different, there's not just one answer to this, right? There's a whole lot of solutions. Now, and actually, I could even start throwing in negatives. And there's actually an infinite amount of solutions to this, right? Okay. Now, here is the crazy part, okay? If I were to graph all of these, okay, so I'm going to show that real quick. Again, you guys don't have to write this down. I'm going to try to make it as
Perfect as
perfect as
possible.
possible.
I don't think you need to try to do that.
Yeah, no one's perfect.
No, just because he does it anyway.
We crack a window, Todd.
All right, so I'm just going to plot some of these points. And do we understand that there's an infinite amount of solutions to this equation, right? And I could even throw in decimals, right? I could have 4.5 and 5.5.
Whoa.
I'm not going to, but I could. It's not limited to, those solutions are not limited to whole numbers, Okay, I could put 4.5 and 5.5, or 4.2 and 5, all those in between decimals. So I'm going to plot some of these points. So 5, 5. Would be like there somewhere. This is kind of hard to do. And 3, 7. It's going to be like right there. Okay, what about 2, 8? Okay, and I'm just going to throw some other ones in here that will work. So I know 1, 9 would be a solution, right? Okay, what about 0, 10?
Yeah.
Okay. So I had 3, 7. What about 4, 6?
I guess.
Would that be a
Yes.
solution?
Yes.
Okay. What about 6, 4? Yep. And 7, 3. Okay. And I could keep going on, but you guys see the pattern?
It makes a straight line.
Okay.
Really?
Yes. Do you not see?
He doesn't make it look straight.
Exactly.
It should be straight. Okay. This is a linear equation. All the solutions to that equation are points on the line. So that is kind of a major point that I want you guys to understand. If you were to graph all these solutions, it's going to be points on the line. Okay? Any equation is going to work like that if you were to graph it. So for example, another linear equation. That's a linear equation, right? If I were to find the ordered pairs that are solutions here, they would be points on the line. Okay? So for example, 0, 4 would be a solution. Okay? That would be a point on the line. Okay? That's how graphing works. So major idea that I want you to understand, any solution to this equation is a point on the graph. Okay? Okay. So we're going to tell whether the ordered pair is a solution to the system. Okay, so to tell whether this ordered pair, for it to be a solution to the system, it has to work for both. Okay, so if it's a solution to one equation but not the other, then it's not a solution for the whole system. So all you have to do here is plug these numbers in for x and y, and then check and see if it works. So I'm just replacing the x and the y with 5 and 1. And does that work?
Yes.
Okay. And then plug it in here. So 2 times 5 minus 1. Does that work? Okay. So yes, 5, 1 is a solution to the system. Be careful on these, because if you look at your ordered pair, your x is first, right? X and then y. And when you come over here, the y is in front, and so you got to make sure you put them in the right order. So just plug them in. Our y is -5, and then your x is -1. Okay. And if we multiply, this is +2 plus 2 is 4. So no, that does not work. And if it doesn't work for, well, I probably shouldn't use an x. If it does not work for 1,
It's not gonna work for the other.
well, it might work for the second one. Okay, because if I plug this in, 3 times -1, that's -3 minus 2. That is -5. But for it to be a solution to the system, it has to work for both.
So there's no point working it out.
Yeah, exactly. So if it doesn't work for one, you can stop there. Now we're going to move on to the graphing part. This is really what we're focused on. So solving systems by graphing. Okay. So what I want to focus on here, I want you guys to sketch a graph. Okay. And it doesn't have to be very big. We're not going to like actually graph exact points. I just want to sketch a couple lines and show you in general how this works. Okay. So I'm going to make one line kind of going downward like that. Again, it doesn't have to have exact points on it. And I'm going to make another line kind of crossing it somewhere like that. Okay, so there's a couple ideas that I think are really, really important for us here. And the first is that if I look at one of my lines, okay, all of the points on this line, every single one, all of those ordered pairs are solutions to that equation. Okay, the equation that you would get to graph that line. So each ordered pair, or so I'm just going to put the line represents all solutions to that equation. And that's kind of like what I showed earlier. Like I had that equation, we found all those ordered pairs, and then if you graph it, it's that line. So each ordered pair on that line is a solution to that equation. And our other line represents all solutions to its equation. Okay. So there's going to be a different equation for each line. And here we've got all of the solutions for one equation. And here we've got all the solutions to another equation. Okay. And if I want the solution to the system, it's going to be this point where they intersect, okay? Because that point is a solution to this line, and it's also a solution to this line, okay? So out here I'm going to write point where they intersect is the solution to the system. Okay, so for these problems, you're going to be given two equations. And I want to find the solution to that, which means, hey, I want to know what answer, what x and y value will work for both of those. You know, what x and y can I put in there that will make both those equations true? And one method for doing that is graphing. So we're going to make a graph. So 4x4 graph should work here. And then we're going to use our methods of graphing from chapter 3. So usually slope-intercept form is going to work better for us. Okay. So I'm going to start off graphing that line. So just kind of a quick refresher on graphing using slope and y-intercept. Start with your y-intercept. So -2. So you start where it crosses the y-axis at -2. And then we use our slope, which in this case it's 1,
For 1.
which if they're both positive, that positive is up and right. So up 1, right 1, up 1, right 1, up 1, right 1. And you may need to get several points on there. I want to be able to get as many points as I need until I find where they cross. So if I need to go this way, I just switch it around and go down 1, left 1. And I'm going to make my line. And then I graph the other equation, because all these points are solutions to this equation. And actually, I'm going to prove that to you real quick. So I'm going to pick a random point. Okay, so Evan, pick one of these 5 points here.
Pick the middle one.
Just pick one.
Pick the middle one.
Hey, I called on Evan.
The
Won't be my
one
friend.
that is +2 on the, yeah.
Right here? Okay, so that point is
We're not friends.
2, 0,
We're friends.
right?
Yeah.
If I plug it in,
I'm just kidding.
it should work.
I'm gonna make myself crazy.
He wasn't prepared for my answer. He just, I don't know. Anyway.
If I plug it in, if I plug in the 2 for x and the 0 for y, does it work?
Yes.
Yes, it does. Any point that I pick on that line would work.
It will.
Okay, so now I want to graph the second equation. So I start with my y-intercept of 4. And then here my slope is -1/1, which means I go down 1, right 1.
That would make sense since it's at the top.
Okay, so down 1, right 1, down 1, right 1, down 1, right 1. Okay. Now, what I would do is I would go through and the point where they cross, I would make really, really dark. Because that point is the solution to the system. Okay? So your answer here isn't just the graphs. The graphing is just the tool to get the answer. Your answer is going to be that ordered pair. So what is that ordered pair?
3,
3,
1.
3, 1.
So really, do you even have to graph?
Yes.
Yes.
You gotta find the point somehow, my guy.
All right. Yep. So the last one here. Now, guys, what I'm going to talk about here, these are both still linear functions, and we graphed ones like this back in chapter 3. But notice how they're not in slope-intercept form anymore. You can graph using standard form, but I will tell you most of the time it's going to work a little bit easier if you put it in slope-intercept form. Okay, so what I'm going to recommend is that you rewrite these. So I would just rewrite them out to the side. I need to solve for y, so just to get y by itself, I'm going to subtract x. Is everybody all right with that? Just subtracted the x to the other side. Now I need to divide by -2. And that's -1 divided by -2 is positive 1/2.
Plus 3.
Is everybody all right with that?
Yeah.
Okay. And then for my second one here, if I subtract 3x, so I get 2y.
Equals -x.
divide by 2. So that's going to be negative 3 over 2x minus 5. Okay. A 4x4 graph actually should catch it all. Okay. So
On our homework, do we have to draw the graphs?
no, the graphs will be there for you.
That's cool.
Thank God.
All right, so start with your y-intercept of 3. So I'm just graphing this first equation. So start with your y-intercept of 3. And then my slope is 1/2, so I go, that's positive, so up 1, right 2.
Then you go down the line.
Yeah, but now notice how I'm kind of out of room.
Then you go down.
Then go down. Down 1, left 2. And down 1, left 2. Okay. So that line there and all of those ordered pairs would be all of the solutions to this first equation. Okay. Now graph the second one. So I start with my y-intercept of -5. Oh, I did not make enough.
5 by 5.
Okay. So my y-intercept needs to be -5. And then my slope here is -3 over 2, which would be down 3, right 2, and I can't.
So now you go up.
So you go up.
Everybody does.
Very good.
So up 3, left 2. Now you have to keep going until they intersect. So if I go up 3 again and left 2, that's that point there. And I'll go ahead and tell you guys, for right now, I believe all of these should, they should come out. There should be a point like that that they both land on, okay? And one thing to be careful of, and I still have to be careful of this because sometimes I forget, just graphing isn't your answer. I need to go ahead and write, what is the solution to the system?
-4, 1.
-4, 1. Okay. And that's it.
Dude, Alan Keller.